Rim, are you there?
Yes, sir.
Okay. So today we are going to start the new topic of this aldehyde, ketones, carboxylic acid. We have completed aldehyde and ketones. Today we are going to deal with carboxylic acid. So see, what is carboxylic acid? If you see this alkyl group connecting with COOH, that is called carboxylic acid, a functional group. So first of all, we are going to deal with its nomenclature as usual. Nomenclature. So in IPSC nomenclature, the name is like alkane plus oic acid. Alkane plus oic acid, that is alkanoic acid. Okay. In this way, we do nomenclature of this, and now I'm going to give you some nomenclature. So it's very easy. So can you do the nomenclature of this, or Rim and Madiha? Yes, carboxylic acid, since it is a functional group, so any functional group present with multiple bond, we give preference to functional group. So here we are going to do, here we are going to give preference to the functional group. Rim, what is the answer for the first?
Butanoic acid.
For the first,
Yeah.
how many carbon in the first one? Yeah, it's
Oh,
correct,
for the first
Madhya.
one.
Yeah, and then we just started carboxylic acid.
Okay, sir.
So I give 5 compounds for the nomenclature. I think you can do this. No, it's wrong, Madhya. How many carbon present in the first one? One carbon, so it's meth. And since carboxylic acid present, so it will be methanoic acid. Okay. See, I'm going to do the nomenclature of this. As you can see, this is the first carbon. We are going to give preference to the functional group 1, 2, 3, 4. So there is no branch. So jump to the parent chain. How many carbon viewed? And then go to the nature of bond. On the second carbon, it is in. And on the first carbon, it is oic acid. So we can write due to enoic acid. Please tell me the name of the third one. Very good. How many carbon in the parent chain, Madhya? See, if you're going to do the numbering 1, 2, 3, 4, 4 carbon is there. First, you write the name of branch. So here, this is the branch. So I'm going to write 2 bromo. Then jump to the parent chain. 4 carbon. And at third carbon it is doubly bonded due to 3 in 1 oic acid. Is that clear to everyone? Now see, this is, we can write benzene carboxylic acid. Whenever you are unable to count the carbon in parent chain of the carboxylic acid, then we write carboxylic acid, not oic acid. And its common name initially was its common name is benzoic acid. Now this common name is treated as IUPAC. So either you can write benzene carboxylic acid or benzoic acid. Now again you can see this is your 6 carbon ring. So it will cyclohexane, and since we are unable to count this carbon, so it will be cyclohexane carboxylic acid. Cyclohexane carboxylic acid. Is that clear to everyone? Is this clear to everyone? Please do respond.
Yes, sir.
Thank you. Can I change the slide? Please do let me know when you are done with this. Aman, Rim, and Madhya, are you done with this?
Yes, sir.
Yes, sir.
Now, I'm going to see the structure of this carboxyl group. The structure of carboxyl group, it's very easy. So as you know that this bond is connected with alkyl group, and this is your double bond, and this is your O, and this is your H. And you also know this will have two bonds. So there will be resonance. This oxygen will take electron from carbon. So carbon will have deficiency of electrons. So this will move to this. So in this way, let me show you in different steps. As you can see, this will be like this, O negative, this valence is free, and this is like this. And also it's very important to note that this will have a positive charge because it gives electron to the oxygen. And again, you can see this will move to this, and then you can see this will be negative, this is free, and now this is double bond O, and then positive. There will be positive since oxygen gave the electron. So this will be the situation, and you can see that there will be resonance like this. Again, this will move to this, and this will move to this, and in this way, carboxyl group stabilizes itself with the help of resonance. Please do write. Then we will go for MOP. Let me know when you are done with this. MOP stands for methods of preparation of carboxylic acid. MOP stands for method of preparation. Please do let me know when you are done with the structures.
Done, sir.
Very good. Everyone done with this? Amen. Now we are going to see the MOP, that means methods of preparation of carboxylic acid. And the first one is from primary alcohols that you have already studied. Primary alcohols and aldehydes. As you know that you have studied this in chemical properties of alcohol and chemical properties of aldehyde, that when you are going to use a strong oxidizing agent in a primary alcohol, on a primary alcohol, you will get directly carboxylic acid. And if you are going to use a mild oxidizing agent on primary alcohol, it will be converted into aldehyde. And if you are going to again use that mild oxidizing agent on aldehyde, then it will be converted into carboxylic acid. So I'm going to write directly RCH2OH, which is a primary alcohol. And if you are going to use a strong oxidizing agent like alkali, KMnO4, alkaline KMnO4. And the second place, you are going to do the hydrolysis in the presence of acid. H3O positive, H3O positive is there. What will happen? This primary alcohol will be directly converted into carboxylic acid. Let's take an example to understand this situation. CH3, CH2, COO. You can see, sorry, a primary alcohol, which is propane. This will be directly converted into a carboxylic acid, which contains 3 carbon, that means propanoic acid. So it will be oxidized CH3, CH2, and COOH. Hydrogen will be removed, oxygen will be added. That oxidation. Is that clear? And there is another reagent which whose name is John's reagent. John's reagent, and the reagent is basically CrO3H2SO4. If you are going to use this reagent on a primary alcohol, then it will be also converted into carboxylic acid. As in case, I'm going to take an example. If you have a primary alcohol and you are going to use John's reagent, and John's reagent, always remember this is CrO3. There can be a direct question, what is John's reagent? Or it can be asked in MCQs, which of the following is John's reagent? So it will be converted into directly carboxylic acid. Is that clear to everyone?
Yes, sir.
Do let me know when you are done with this. And you know how to prepare this aldehyde to carboxylic acid. Then, or you can use strong oxidizing agent on aldehyde also. Madhya, how was your paper? How does it go? How did it go? The chemistry paper. Can you tell me to the maximum marks, total marks, full marks? Was it pre-board? Okay, very good. Please do let me know when you are done with this. Everyone done with this? Simon, Rim.
Yes, sir.
Okay. Now see, if you are going to use If you're going to have an aldehyde, either you can use mild oxidizing agent or the same alkaline KMnO4. This will be directly converted into carboxylic acid, propanoic acid, CH3CH2CW. This part we have already studied. That's why we can move ahead, right? Aman, Rim, Madiha. Okay. Can I change the slide?
Yes, sir.
Okay. Now see, basically the second method of preparation is from alkyl benzene. And always remember, whenever you are going to prepare this carboxylic acid, you need to oxidize alkyl benzenes. And how we are going to oxidize? Let's say this is your toluene or methyl benzene. You can say this is your methyl benzene. So in order to convert this in carboxylic acid, we need to oxidize it. And to oxidize this alkyl benzene into a carboxylic acid salt, we will use KMnO4, potassium permanganate, KOH. That means alkaline potassium permanganate, and heat it. So what will happen here? All the hydrogen will be eliminated. All the hydrogen will be eliminated, and with carbon, double O negative and K plus will be added. This is your basically salt. And after getting it, you are going to do uh, acidification. That means basically H3O positive reacting it with acid in the presence of water. So this K plus will be directly replaced with H, and in this way we get benzoic acid. Benzoic acid. This is a very strong oxidizing agent. Is that clear? Now I am going to give you a question. The question is very important. If you have CH2, H2, CH3, and you are going to use again the all same like KMnO4, KOH, and heat, then what you will get? So I'm going to explain. Always remove the hydrogen from the carbon which is directly attached to the benzene, not this carbon or this carbon. There is a reason. I will explain. So let me complete this reaction first, then I will explain why does it happen. So this will be directly converted into COO minus and K, and this will be broken and formed as a byproduct. And then again you are going to pass this through H3O positive, and K plus will be converted into replaced by OH, and here you can get your benzoic acid. Please be focused here. Why I didn't remove this hydrogen? If you are going to remove this hydrogen, first write it, then I will slide it down and then explain. Let me know when you are done. Ayman and Maria, let me know when you are done with this. Maria, Ayman.
Yes, sir. Done.
Very good. So what I want to say is that why this carbon that is connected to benzene ring directly is oxidized, not other carbons. That's because this carbon is in conjugation. This carbon, basically, if you are going to oxidize this carbon, this will form like this. And this carbon is basically in conjugation with the benzene ring. In conjugation with the benzene ring, that means there will be resonance and it stabilizes. If we're going to oxidize the middle carbon or the last carbon, if you are going to oxidize the last carbon, there will be resonance, but only in this part. But here, there will be resonance in this part as well as this part. So due to the resonating structure or resonance, this is more stable. That's why we always oxidize the carbon, which is directly attached to the benzene. Is that clear to both of you, Ayman and Madiha? Ayman, Madiha.
Yes, sir.
Okay. Can I change the slide? Please do let me know. No, do let me know when you are done.
Yes, sir. Done.
Very good. Now see the next preparation. From nitriles and amides. Nitriles, CN. Amides, CONH2. So this is your amides. So if you have a nitrile like this, so you react this in the presence of either acid or base. And you are going to do hydrolysis. Hydrolysis in the presence of acid or base. So this nitriles will be directly converted into amide. And after getting amide, you are going to again react this with either acid or base and heat it. Either acid, H plus or OH minus, and you are going to give heat. What happens here? It's very easy to understand that this will be broken. As you can see, this will have negative sign and this will have positive. Okay, so this negative will come to this positive and it will form RCOOH. And there will be, this will go with this and formation of NH3 will take place. In this way, we prepare carboxylic acid from nitriles. And when you are going to prepare carboxylic acid from amide, you can see you just need to do hydrolysis in the presence of acid base. So if I'm going to give you CH3 CN, you will get a product A that will be amide, and after this you will get B. Please write the IUPAC of A and B. Please do let me know when you are done with this. Are you done with this? So see, this will be converted. As you can see, CH3CH2 will be as it is, and this will be converted into amide. And after this, you will get NH2 will be converted into NH3. And at the place of NH2, you are going to add, this is your CH2, this is your CH3, and this is your OH. Okay. Is that clear? My video is lagging. Is my video lagging? Aman, are you able to see my screen?
Sorry, sir, I can't hear you.
Can you see the screen?
Yes, sir, I can.
What about you, Madiha? Madiha, please do respond. Am I audible to both of you?
Yes, sir.
Are you done with this? Madiha and Aman. Aman, am I audible? Are you
Yes,
done
sir.
with this?
Yes, sir.
Okay. Now see, the next preparation is from amides, and we just did from amides. First nitrites will be converted into amide, and amide converted into carboxylic acid. So if I will directly give you CH3CONH2, can you convert this H3O positive delta into carboxylic acid? Can you do the reaction? It's very simple. What you need to do, you know that. CONH2. Please do let me know when you are done with this. I'm waiting. Ayman, are you done with this?
Almost, sir. So we'll get CH3COH plus
Yes.
NH3.
Double O plus NH3. And this it's also very easy. This will be converted into COOH and plus NH3, right?
Yes, sir.
Now the next part is basically the fourth is from Grignard reagent. From Grignard reagent. So as you can see from Grignard reagent, first you are going to react this Grignard reagent with CO2, dry ice. That means solid carbon dioxide. And see, the reaction will occur in dry ether since Grignard is reactive. So what will happen? It's very easy. As you can see, this oxygen will take electron from carbon, and this will have positive charge, and this will have negative charge. And magnesium is metal, so this will have positive charge. Are you getting my point?
Yes,
Let
sir.
me do this. It will be more convenient. This oxygen will take electron. So as you know that this negative will go to carbon because it will have deficiency of electron, and this positive will come to oxygen because it will have negative and this will have positive. Is that clear? So now I'm going to write C double bond O, and this will be O negative since it took the electron from carbon, and there will be Mg plus and then X, and this R directly attacked on the carbon, so there will be like this. Is that clear? Is that clear, Aman?
Yes, sir.
And after this, you are going to do the hydrolysis. H3O positive. So you know you have two parts, H plus and OH minus of water. So as you know that this H plus will go to this and this negative will go to Mg. So what you will get RC double bond OH plus MgOHX. Got it? In this way, you can do the reaction. Please do write. Is this clear to you? Can I change the slide?
Yes.
Okay, so if I'm going to give you CH3 MgBr reacting with CO2, that means C double bond O, you will be getting A, and then you are going to do the hydrolysis, then you are getting B. Yes. Can you do this reaction? If you are unable to do this, please do let me know. Can I change the slide? Simon, see what will happen. There will be positive, there will be negative, there will be positive, there will be negative. So this negative will come here and this positive will come here. So as you can see, C double bond O, and O has a negative sign with Mg plus is going, and Mg with Mg plus Br is there, and there will be CH3. Now if you are going to do the hydrolysis, that means plus and OH minus. And you know the drill that this negative will move to this positive will move to the negative, and this negative will move to the positive. So what you will get, CH3 C double bond OH, that means ethanoic acid along with this byproduct, that is MgOH. Is that clear? Please do let me know.
Okay, sir. I'll write it down then.
Let me know when to change the slide. Are you done with this?
No, sir, not yet.
Okay. Let me know when you are finished with the above. Can I change the slide?
Yes, sir.
Simon? This is not test. Basically, I'm going to 12 to 15 minutes. Just try this reaction. And whenever transformation or conversion is given, first write the reactant and then product and think how you can convert that. Are you getting my point?
Yes, sir. Okay.
Right. Yes. And these reactions are very important. Aman, are you done with this? Have you done the question?
So what?
Let me know written with when you are done with the question. Okay.
Okay, sir.
Okay. You have 15 minutes for this. Okay. Only 15 minutes.
Okay, sir.
know. Aman,
Yes, sir.
are you able to solve it?
Sir, not question number 2.
Did you solve the first one?
Yes, sir, I solved the first one. And the third and fourth. I'm solving the fifth one.
Okay. I will explain more. Very good.
Yes, sir.
So let's see. Butane 1 all to butanoic acid. Just match your butane 1 all to butanoic acid. It's very easy. Very easy. You can see this is your butane 1 all, which is a primary alcohol. And you are going to use John's reagent. And you know what is John's reagent? That is CrO3 H2SO4. And it will be directly converted into carboxylic acid, butanoic acid. It will be directly converted into butanoic acid. You can also use alkaline KMnO4 and hydrolysis after that. So what you have used? Did you do the same or you used another reagent? Are you there?
Yes, sir.
So have you done the same or something else? Is
Yes,
it
sir. The
correct?
same. Yes, sir.
Okay. Now see, benzyl alcohol. So first of all, you need to write the structure of the benzyl alcohol. This is your benzyl alcohol. And we need to prepare from benzyl alcohol to we need to prepare phenylethanoic acid. So see how we are gonna do. It's very easy. So I'm going to react this with HBr. HBr. So what will happen? This OH will be replaced by Br and OH and H combine to form water. So we will get this H2Br. After this, we are going to react this with KCN. So what will happen? You know that this will have negative, will have positive, and this will have negative KCN and this will have positive. So this negative will go with positive and KBr, the byproduct in this process, in this state. And you can see you got CH2CN. Now it becomes nitrites. And after nitrites, you know what we did, what we do, benzene cyanide it is, what we do, H3O positive and he. Or else you can see the preparation of carboxylic acid from nitriles. First, it will be converted into, you saw that this is H plus or OH minus, and then you will get amide. How you will get amide? It's easy. This is your CH2 and this is your C double bond O NH2. And after this, you are going to heat it in the presence of this H3O positive. Then you will get what you will get carboxylic acid, which is, you can see, this is your benzene as it is, and there was CH2, and this C double bond OH will be converted, C double bond ONH2 will be converted into carboxylic acid. So you can see this is your 1,2 is phenyl, 2 phenyl ethanoic acid or phenylethanoic acid. Is that clear? Please do write it. I think there is a doubt in this, right? Are you done with this?
Yes, sir.
No. Now see the third one is basically what? The 3-nitrobromobenzene to 3-nitrobenzoic acid. So 3-nitrobromobenzoic acid. So this was the situation. You can see this is your bromine, and with respect to 1, 2, 3, nitro will be here, NO2, and since it is benzene, now it is benzene. So first I'm going to react this with magnesium in the presence of dry. So what you will get, it's very easy. This magnesium will go with bromine and it will form now a Grignard reagent, MgBr. MgBr. With this MgBr, you are going to react this with CO2, that means C double bond O, like this. Dry ice, basically. So you need to do, just see, this will move to this will have positive sign, and this will have negative sign. This will have positive sign, and this will have negative sign. So what will happen, as you can see, C double bond O negative is here, and with O negative, Mg will go Mg plus Br minus, Mg plus Br minus, O minus Mg plus. And with this, you can see the benzene ring will come like this. And with respect to this, there was NO2, so it will be written as this. After this, you are going to do the hydrolysis part. That means H plus will go with this OH, and you will get, as you can see, what you will get. You will get C double bond OH, and NO2 was there. So this is your 3-nitro benzoic acid. Sorry, benzoic nahi. No, ben 1, 2, 3. So it will be 3-nitro-benzoic acid. Is that clear? Please do let me know.
Okay, sir.
Now you can see the next one. Is this correct? Have you done it correctly?
I just missed the middle steps, but yes, everything else was right.
Okay. Please do write it and then let me know. Can I change the slide?
Yes, sir, done.
Okay. Now there is a question that is 4-methyl acetophenol. So first you need to write the structure 4-methyl acetophenol. That is 4-methyl. With respect to this position 1, 2, 3, 4, this is your methyl, and acetophenol has a that is acid. That means 2 carbon that comes in under common. So you are going to do KMnO4 and H2SO4 and heat. So you know that this hydrogen will be removed. This hydrogen will be removed, and it will be converted into C-double-OK. It will be converted into C-double-OK. In the same way, this will be removed and it will be oxidized to C-double-bond-OK, which is a salt. And now what you need to do, it's very simple. You are going to do dilute or you are going to do the hydrolysis in acid. So this K will be replaced with OH. This K will be replaced with OH. So this will, that is 1, 2, 3, 4. So we can write benzene 1,4 dicarboxylic acid. Since we are unable to count the C of carboxylic acid, so dicarboxylic acid, or its common name is quite famous, that is terehalic acid. Is that clear?
Yes, sir.
Have you done it correctly? Now
Yes,
the
sir.
last one is very easy. Butanol, the last very easy. Butanol CH3 CH2 CHO. And you convert this in carboxylic acid. So you have two ways, whether you can use alkaline KMnO4 or ammonium silver nitrate, CH3 CH2 CH2 COOH. Or either you can use the Tollens reagent, that is basically your AgNO3, in which this will be oxidized to carboxylate anion CH3 CH2 CH2 COO minus, and then H plus you are going to use the hydrolysis, and then it will form CH3 CH2 CH2 COOH. Is that clear? So it will be converted into butanoic acid. And this is your butanol. Have you done it correctly?
No, sir.
Okay, then please do write it. After this, we have two more ways for preparation of carboxylic acid. And in the next class, most probably we will complete this chapter. After this chapter, we are going to have amines.
Okay, sir.
Okay, so do you have any other doubt? Please do let me know if you have any doubt. And do you have any doubt?
No, sir.
Okay, so this is it for today.
Okay.
Your